Just we are starting Chinese remainder theorem, right? So first we have to understand exactly what is this Chinese remainder theorem and how to use this Chinese remainder theorem and what type of question Olympiad and other examination will ask based on this, right? This is so important, in every the remainder question or the question on the last two digit you have to find or last three digit of the number you have to find, right? You have to apply almost in all the cases you have to apply this Chinese remainder theorem, right? So if we are going to just settle down the things exactly what is this Chinese remainder theorem in mathematical form, if I'll say let n1 n2 n3 up to nr be positive integers such that GCD of any of Ni or Nj is 1 for all I not equal to j, right? I not equal to j in linear congruence. Means if you want to divide the numbers with n1, n2, n3 or nr and none of the number, right, having the GCD other than 1.
दरवाजा लगाओ.
If we have to, right, if we have to just take two numbers, right? One number is 2, other number is 5, one number is 3, 5, 5, 7, and other, like these type of numbers are given when the GCD of the number is 1, right? Right, as such as x is congruent to a1 mod n1 means when I'm dividing the number x by n1, I'm getting the remainder a1. X congruent to a2 mod n2 means when I'm dividing the number x by n2, I'm getting the remainder as a2. So on up to x1 divided by nr means mod nr, I'm getting the remainder a, right? So this is the number, right? If x congruent to a1, x congruent to n a2 up to x congruent to ar with the mod n1, n2, n3 up to nr, right? In a mathematical form, it is written like in the number form. I can say you'll be able to understand wisely in this if I'll write as if I'm saying x congruent to 2 mod 3 or x congruent to 3 mod 5 and x congruent to 2 mod 7, right? When you are dividing same x with 3, 5, and 7, you are getting the remainder 2, 3, and 2. Then what is the number x, right? So I hope you all understand exactly what is this, right? Now, so how what Chinese remainder theorem says, right? If any n is equals to, right, this multiplication of all the numbers n1, n2, n3 up to nr, obviously all having GCD 1, so n will be now no common factors are multiplying in this, so n is equal to n1, n2, n3 up to nr, right? And we are assuming any n of k as n upon nk, right? Any number capital Nk is represented as n upon nk, where k is equal to 1, 2, 3 up to r, right? And obviously we can say कि GCD of nk to nk capital to 1, this is 1, right? So linear congruence to nkx1 mod nk. right? If this is some nk, we are able to find some nk. So maybe you'll find difficulties when we are just going with the right, just going with the numbers, right? Maybe you'll find difficulties on that, right? So, right, careful. Now, when we'll come to the question with 1 divided by 2, 3, 5 and all, na? So you'll be able to like link the things exactly. So what Chinese remainder theorem says, it says that x is equals to a1 n1 x1 plus a2 n2 x2 up to ar nr xr, right? Where xk is nothing but nk into x congruence to 1 mod nk. This is the theorem. This is the theorem, right? How to use this, what are the meaning, like what are the symbols says, right? It's a pure mathematical form I have given exactly how this is working, right? Now, note down everyone. So, okay. So what is this NR, NK, N, and blah, 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 and how to find this? So for that, I have given one of this question, something like this. When I'm saying X congruence to 2 mod 3, X congruence to 3 mod 5, and so on. So what is this N? Then a small n in this case will be 3 into 5 into 7. This 3, this 5, this 7. This is right. First, when I'm saying, right, N1, N1 means I have not to write this number 3. N1 means I have to divide the number completely 357 by 3. So N1 I'm getting as 35, 5 into 7, right? A1 in this case is nothing but 2 only, right? The A1 is this one, right? And X1, right? X1 we have to find. How to find this X1? X1 means when I have to find this X1, as I say, I have to take this N1, 35 into X1, congruence to 1, right? Mod 3. This is also called inverse of this, inverse of N1, right? Which books me, if you'll see, right, which books me, you'll see that this is, I'll send you, Sanjana, I'll send you, now, beta. Now, so I'm going through this question, okay? Right. In few books, you'll see in this formula, if it is given N1 and X1, this X1, they will write inverse of this, N1 inverse. The meaning is same, the properties are same, right? So how to find this X1? So obviously, we know that when I'll just divide, we can write this as 36 X1 minus X1 congruence to 1. And this 36 X1 is divisible by
3.
right 3. So you are getting minus X2 congruence to 1 mod 3. So X2 is congruence to minus 1 mod 3. Is this okay? Right? So this minus 1 mod 3. So what is the value of this? Right? So what we can say X1, sorry, this is X1.
Sir,
right?
x1 is congruent to 2 mod 3.
Very good. 2 mod 3. Okay. So the x1 is 2 in this case, right? The value of x1, right? Similarly, if I'm going for the second, right? When x congruent to 3 mod 5, right? Then I have to find n2. N2 is, I have not to write this 5. So this will be 7 into 3 will be 21, right? A1 in this case is, it was given as 3. And now I have to find x2 in this case, right? This is A2, right? This x2 I have to find as 29 x2 congruent to 1 mod 5. So this x2 is congruent to 1 mod 5. Okay, everyone? Right? So now this is your turn, right? Everyone, right? Find N2, A2, and X2 for third case. Go for that. I'll request everyone, please switch on your cameras. Very good, Patyus, Rishabh, very good. Aryan, very good. Aryan, एक बार चेक करना बेटा.
Yes, sir.
Vijay, very good. Utkarsh, Jayesh, this x congruent to 2 mod 7. So I can say in third case, N3 is nothing but 15. A3 is given as 2. And x3 we can find as 15 x3 congruent to 1 mod, right? It was 7. Right. So when I'll divide this by 7, I'm getting x3 congruent to 1 mod 7. Right. Now you have to put these thing in the formula, right? First you are getting, right, this one. Second you are getting this one, right? X2 is 1 in this case. And third you are getting this one, right? See what number you are getting from this, right? So you have to apply the formula x is equals to,
Sir,
yes,
sir, why did you take x1 as 2 only and not any other like number like 5?
x1 x1 2 calculations are beta 20 21 when divided by 5 it will give you 1 only, right? Remember, so 1 into x2 congruent to 1, that's the reason x2 is coming as 1.
Okay, sir.
In this case, if you'll see, when divided 15 by 7, you are getting x3 only. So x3 is congruent to 1. Right? So what number I'm getting? Right?
Sir, 15x3 should be 2 mod 7, no?
15x3.
Sir, you had given 2 mod 7, 15x.
Then the question you had given 2 mod 7.
नहीं बेटा, आपको हमेशा जो ये निकालने हैं ना n1 x1 थ्योरी में देखो फिर से एक बार.
Sorry.
You have to find this n1 and x is congruent to 1 mod 7. That is a1 a2. ये x1 के लिए always you have to find the inverse. That's the reason I said this inverse. Inverse means what number I have to multiply to this to, you'll get number 1. Getting my point? What number
Yes.
you have to multiply in place of x1? So that's you are finding the inverse of that, right? So x is right. You have to multiply the numbers, right? So for first one, what was that? N1, 35 into 2 into 2. यही था ना तीनों numbers? Yes.
Yes, sir.
21, 3, 1. 21, 3, 1. Then last one is 15 into 2 into 1. So this is coming 140, 63 plus 30, right? But that we have to find for mod 105. What is this 105? This is a multiplication of the number what we are getting. So when I'll divide this number by 105, what remainder I'm getting? That is 23. Means the number x is in the form of 105 lambda plus 23. All the number is in the form of this. Is this okay, everyone? You understand the meaning of this, right? And this is the your Chinese remainder theorem. Just little bit calculation and all, right? But we have to go for the easiest calculation, right? Is this okay?
और आपने सब पहले कराया भी हुआ है ना?
Okay, everyone, right? Yes, बेटा पूरा पढ़ाया हुआ है, ये रिवीजन चल रहा है नंबर सिस्टम का. Now go for the question, right? And this time, obviously, you have to be fast with this. When like you have to find x congruence to 1 mod 3, x congruence to 2 mod 5, and x congruence to 1 mod 7. Find x. The variation of this is like the question they will ask in the different forms, right? So in the quadratic residue, in the form of last 2 digit, 3 digit, as I said, right? Everywhere we have to use this Chinese remainder theorem. And in the practical questions also, right? I'll show you where to use. Tanmay, okay?
Yes.
Shama, assess, Katani, is this okay, beta?
So we have to find the smallest value of
Yes. Just application of Chinese remainder theorem, right? Very good, everyone. Very good. Anushka, very good, beta. Tanmay, very good. Sage, very good. Pratyush, very good. Real answer. Tanay. It has not to come in minus, beta. Because like it has to come in the plus with the plus sign. Aryan, very good. Jayesh, calculation check karo, beta. Rishabh, very good. Right, only the calculation part again, right? So we have to write down N1. So first, N1 is again 35. right? A1 is 1 and x1 in this case means 35 x1 congruence to 1 mod 3. So this x1 is, what is x1? What is x1 you are getting,
2.
2.
right? And 2 is 21, a2 is 2. What is in this case 21 x2 congruence to 1 mod 5. So this is, so directly you can say that 21 is 1 divided by 5, it's giving you x2 congruence to 1 mod 5. And third case, n3 is 15, a3 is 1, and 15x3 congruence to 1 mod 7. So again, x3 is coming as 1. Right? X1, X2, X3, N1, N2, N3, all the numbers are there. So I hope you all know what to do now. So from first one, you are getting 70. From second one, you are getting 42. And third one, you are getting 15 only. Right? And this you have to divide by 105. So you are getting 22 mod 105. How many of you got this? Sanjana, calculation. Okay, everyone. Very good, very good. So this is the first type when directly I'm giving, when you are dividing this, blah, 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 and then you are getting the numbers, right? Now, so I hope you all are comfortable with this. I hope you all are comfortable. Now, the application, right? With the basic application. 17x congruence to 9 mod 276. Solve for x. Try to apply the concept on this question. Say count division. प्रत्युष, कात्यायनी, तन्मय,
Just
सर
श्रेय।
सर प्रत्युष का माइक काम नहीं कर रहा।
वेरी गुड बेटा, बहुत अच्छे। आर्यन, वेरी गुड, वेरी गुड, बहुत अच्छे। नंबर डिविजिबिलिटी से बड़ा नहीं होगा ना बेटा। जो नंबर आया उसे 276 से डिवाइड करके देखो रिमाइंडर क्या आएगा। नहीं, you can see that ki exactly what remainder we are getting from that. Okay, everyone.
सर
Done.
1 सेकंड।
Very good, Utkarsh. Anushka, divide that number by 276. So in this case, what we have 17x congruence to 9 mod 3, 17x congruence to 9 mod of 4, and 17x congruence to 9 mod of 23, right? So again, what we have to do, n1, a1,
बट सर इसको 6 into 2 into 23 भी लिख सकते हैं ना?
you have seen that, and x1, and e2, n2, and x2, and all the three numbers we have to, like, we can find all the numbers, right? First one, what I can write, the first one is what we can write this as 17x congruence to 0 mod of 3, right? 17x congruence to 1 mod of 4, 17x congruence to, इसमें तो कोई उपाय नहीं, 9 ही रहने हैं, 9 mod 23, right? Then we have to find x1 in all the cases, right? Then almost सभी के आंसर्स आ चुके हैं, but फिर भी एक बार जल्दी से देख लूं, right? N1 is 92, A1 is 0, and X1 in this case, what X1 you all are getting, right? So 92 X1 congruence to 1 mod 3, right? 2x is equal to, so this, right? So 2x1 congruence to 1, or this will be 2 only, right? N2 is 69, A1 is 1, right? 69x2 congruence to 1 mod of 4. So this is coming as 1 only. And third is 12. And this was 9, I guess. No? And third, 12x3 congruence to 1 mod 23, then 2. That's coming as 2. Okay, everyone? Right? Now we have to find value of this, right? So the value will be, right? X is nothing but n1 x1 summation of ni, summation of ni xi ai, or this is the inverse of, right? This is x. So first one is 0 plus 69 into 1 into 1 plus 12 into 9 into 2, right? 69 plus 216, right? क्या सही नंबर आ रहे हैं सबके? What number you all are getting this? I guess 33.
यस सर. सर मैं कुछ डिफरेंट अप्रोच ट्राई किया.
क्या किया बेटा?
सर मैं क्या किया कि 276 मॉड 17 निकाला तो वो 4 आया एंड देन फिर उसको लिख दिया 276 इंटू n प्लस 9.
चलेगा. तो
उससे
सेम वो लास्ट लेक्चर में हमने वही किया था, याद करो. ये फॉर्मल तरीका मैंने बता दिया कि एग्जैक्टली हाउ दिस विल वर्क, राइट. एंड आई होप यू ऑल आर लाइक कंफर्टेबल विद दिस, राइट. कितने भी बड़े नंबर्स होंगे वी आर एबल टू जस्ट फाइंड आउट द नंबर्स, राइट. नंबर हमें मिल जाने चाहिए. अब एज आई सेड कि लाइक कुछ प्रैक्टिकल की बात करें, कुछ प्रैक्टिकल एग्जांपल्स की बात करें, व्हाट आई वाज सेइंग. अगर मैं एक क्वेश्चन फ्रेम करूं, लाइक इफ यू ऑल नो नेचर बड़ा बड़ा ही प्यारा बना हुआ है नेचर, राइट. तो नेचर इज लाइक इट्स फॉर्म्स इन सच अ वे कि इफ समवन इज फ्रॉम बायोलॉजी तो ही विल explain this in better way. If you see na ki like fruits are coming to the any tree or something, right, tree or plants or right, so it's not coming every year. If you'll see okay, like it has to come in like if one tree is giving fruits in 2 years, the other will be giving in 3 years, other will be giving in 5 years, other will be giving in the 7 years, right. All these things is coming into the prime numbers, right. So why this is coming into the prime number? Because like each and every tree is giving the fruits in exactly one time. It's a very lesser number of chances. Then the tree has to grow up, then tree has to like it has to grow in a natural way. So the cycle is going in a such way ki like every time we'll get ki exactly the nature can give you the maximum benefit and the fruits and the trees can take the maximum benefit from the nature. We can think in that way na, ki like if each and every tree is they required the all the resources from the ground, right, in one time, so that will be very difficult. So two questions I'm going to give you in this. First is find the earliest time when 3 clocks one with a 12 hours cycle, right. Second is 24-hour cycle, and third is 30-hour cycle, right. You will show the time same. Well, first time let it is 0, then it will give you the same time after an hour or something, right. So what time it will give you the
सर आप वापस बोल सकते हो, नहीं समझा.
what Jays?
सर आप वापस समझा सकते हो
Yes.
क्वेश्चन.
Find the earliest time when 3 clocks, one having cycle of 12 hours, second having cycle of 24 hours, third having cycle of 30 hours, will show the time, show the same time again. How to use the CRT, Chinese
Sir,
Image
basically,
Recognition?
after how many hours they will have the same time?
Yes, first clock is giving you the time. First clock is giving you the time, the same time in 12 hours. Second is giving you the same time in 24 hours. And third giving you the same time in 30 hours. For what time all the three will show you the same time. So the basic question, you can apply the CRT or not CRT is not. Very good. So the equation is x congruence to 0 mod 12, x congruence to 0 mod 24, and x congruence to 0 mod 30. Right? Okay, so obviously the LCM of all 12, 24, and 30, that will give you the answer because this 0 is going to give in each of the cases. Right, so LCM of 12, 24, and 30 will be 120, I guess. Right? Very right. So you understand now, if I'll give you like x congruence to 1, 2, 3 or something, so same thing you have to use in this, right? So this CRT Chinese remainder theorem, I guess you all are comfortable because we have to use this in the different questions, right? This is not the question itself, but you'll get question on this, right? The second theorem, what we have to understand is the Wilson theorem. Directly coming to the Wilson theorem, this is p minus 1 factorial congruence to minus 1 mod p. We have already proved this, right, where p is prime. Right? P minus 1 factorial, now p is prime, right? So now I'm giving you the question on this directly. This you have to use, right? 101 divided 97 factorial, find remainder. If 97 factorial is divided by 101, what remainder you are getting?
7 factorial is divided by
97 factorial is divided by 101, then what remainder you all are getting? Question is clear now?
Yes, sir.
Okay. Tanmay, check again.
yes sir.
Yes, check again.
Yes sir.
Shreyaj, very good. Yusuf, very good. Patyus, very good. A very simple question, right? No, Katyani, एक बार check करो बेटा.
Yes, sir.
Rishabh, very good. May I? Right? See, these are the like tools that we have to use, right? For different questions. In fact, in this, we know that the Wilson theorem says, विजय देखना बेटा देखो ध्यान से Wilson theorem says कि like 101 is a prime number, right? So I can say 100 factorial when divided by 101, I'm getting remainder as -1. But unfortunately, we are not saying like they are not asking 100 factorial when divided by 101, what you are getting. They are saying 97 factorial. So I can write 100 into 99 into 98 into 97 factorial, congruence to -1 mod 101. See, this is -1. This is -2. This is -3. Right? So all these three numbers into 97 factorial congruence to -1 mod 101. Or I can say this is -6 into 97 factorial giving you -1 mod 101. Or minus we can remove. So 6 into 97 factorial congruence to 1 mod of 101. Now, if you'll see, we can't divide in congruence, right? Congruence means we can't divide, right? So what we have to do, we have to find 6 inverse, right? Same as what we have done in the Chinese remainder theorem, right? What number we have to multiply with 6 to give you 1 with a mod of 101? Or this is x1. Are you understanding this? Is this okay, everyone? Is this okay, everyone? ये आया समझ में? ये समझ में आया? क्योंकि बार बार आपके पास आएगा ना, when you are getting something like this, ना कि this you have to find 97 factorial and one number is there, so you have to multiply with the 6 inverse. But what is the meaning of 6 inverse? 6 inverse meaning is when I have to take a 6 into x1, that's congruence to 1 mod 101. That is the meaning only. That like you all are doing that only, from that only you are getting the answer. But mathematically, this is the notation of that, right? So when I'll multiply this 17 both sides, so 17 into 6 x1 congruence to 17 mod 101, right? 17 into 6 is 102. 102 x1 congruence to 17 mod 101, and we know that 102 is nothing but 10 divided by 101. I'm getting x1 congruence to 17 mod 101. Is this okay, everyone? Right? From the basic principle of that, we can, right, go with the numbers, something like this. Okay, everyone? Right, in the same way, if I'm giving you a question, okay, everyone? Okay. Take your time, take your time.
The remainder is 17.
Yes, beta. 17 ही है ना? Okay. Now, what if I'm giving you one question? Simple. Just you have to go for the calculation. 25 factorial plus 1 when divided by 31 gives the remainder. Right? You have to find the remainder when 25 factorial plus 1 is divided by 31. Very good. Proteus. Very good. Kasev. Only the calculation, basic calculation. So check your calculation. Aryan. Answer.
सर मैं कर ही रहा हूँ सर हो गया ऑलमोस्ट
Rishabh, check your calculation. अनुष्का कैलकुलेशन एक बार चेक कर लेना. शिवांग कैलकुलेशन बेटा. तन्मय डन.
Sir, actually, I went somewhere. Starting.
टेक योर टाइम, टेक योर टाइम. आंसर्स कुछ बहुत वैरायटी के आ गए हैं. Atani, check again. After 2 minutes, you have to write down the answers, right? After 2 minutes. After 2 minutes.
सर
Take your time, everyone. Take your time. Atani, very good. बहुत सारे आंसर आए हैं, but I'm not giving the response because right. See, let's see, right, what number we are getting. Okay, 25. We know that, right? First thing, 31. Number 31 is a prime one. So 30 factorial congruence to -1 mod 30. Right? But I have to reach to 25. So this will be 30 into 29 into 28 into 27 into 26 into 25 factorial -1 mod 30. Right? Or this will be -1, -2, -3, -4, -5 into 25 factorial congruence to -1 mod 30. 1, 2, 3, 4, 5. 5 minus signs are there and 1 minus sign is there. So I can remove that, right? So this 5 into 3 into 2, 30 into 4. 25 factorial congruence to -1, oh sorry, +1 mod 30. And this is again -1. 30 is nothing but -1, right? -1 into 4, that will be -1, or we can say 4 into 25 factorial congruence to -1 mod 30. Is this okay? Means I have to find 4 inverse mod of 30. Right? 4 inverse mod of 30. Right? So 4 inverse mod of 31 is, we know that this is very simple. Again, you can find from 4x1 congruence to 1 mod of 31. Multiply by 8, I'm getting x1, 8 mod of 31. And 4 inverse, I can write this is, right, 4 inverse of this. So this will be -8 mod 31, right? -8 mod 31 is same as what?
23.
That's it. So why you all are getting answer like, right? So 23 and 23 is for this, but I need 23 plus 1, right? So only few answer were there as तैयारी भूल गई थी +1 करना.
हाँ सर.
But good. Simang, there was a minus sign, beta. -8. Huh? Good, Sanjana, very good. I hope you all understand this, but the answer, right, I guess you all have noted this. Okay, done everyone? Right, one more question on this. When divided by 2023. 2023 is a prime or not? Just
Sir, it is not prime.
It is not prime, sir. 7 से divisible.
7 into 17 square.
not 17 as both are coming now. So the theorem will not work for me. 2017. This is prime, I guess.
No, sir.
Not prime?
So divisible.
No,
by-
sir.
Wait.
Just check.
Yes, sir. 2017 is prime.
हाँ सर प्राइम लग रहा है.
सब गूगल कर लियो, सब गूगल किया, सब गूगल चल रहा है।
नहीं
सर,
सर, नहीं सर,
हाँ बिना गूगल के इतना जल्दी आ जाएगा नहीं सर। यस।
नहीं, नहीं सर, मैंने देखा भी ना कि 2017।
हम्म। पट्यूस।
सर मैं तो 13 तक देखा, उसके आगे मेरे को नहीं लगा होगा इसलिए बोल दिया.
ओके ओके, माना मैं।
सर आंसर दे दिया
वेरी गुड आर्यन, वेरी गुड, वेरी फास्ट दिस टाइम।
सर. फॉर्मेट लगा दिया सर. भाई फॉर्मेट क्या बोल रहा हूँ, सर लगा दिया.
डायरेक्ट क्वेश्चन, राइट? ओके एवरीवन, डन 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 डन।
एक मिनट सर.
Do it fast, do it fast, do it fast. Sanjana, check again. Both the numbers are, two, or just check 2 or -2.
सर भेज दिया.
सर भेज दिया आपका.
Check again. See the plus minus sign. Yes. So -2 is 2015, na? Very good, Utkarsh. ये 1 क्या है?
सर गलती से आपको भेज दिया.
गलती से मतलब और भी इधर उधर चल रहा है तेरा चैटिंग?
नहीं सर गलती से टाइप हो गया.
Pratyush?
सर
हाँ सर,
Katani, -2 is same as 2015. Right? So everyone is getting this now. Very good, everyone. Very good, everyone. Like JS, why 1 beta?
नहीं सर,
This
नहीं
is
सर.
giving -1 and this is giving you 1. Right? So 1 is -2.
ओ सॉरी सॉरी सर, मैं गिनना भूल गया.
Right? And the last on this, right? So this is a direct formula based thing. So that's the reason you'll not get question in the variation, but see. 1 by 1, 1 by 2, 1 by 3, up to 1 by 23 is equal to a upon 23 factorial, right? Find remainder when a is divided by 30. This is good one. Take your time, everyone.
सर भेज दिया।
in the chat.
So you are saying, Jayesh, you are saying this is always divisible, beta?
तो जैसा जितना मैं देख पा रहा हूँ उतना हो रहा है।
यस सर, डिविजिबल आ रहा है
और
चिल्ड्रन।
थोड़ा सा और थोड़ा सा देखो, और थोड़ा सा देखो बेटा।
यस सर।
ठीक है
इसमें मेरा
आ तो रहा है सर जितना मैं देख पा रहा हूँ।
सर आप एक बार मेरा चेक कर सकते हो।
अभी देख रहा हूँ बेटा। But you change this cursive 7. Just a minute, और कुछ लोगों के आने दो, है ना। एक बार चेक करना, कैलकुलेशन चेक करना, चेक योर कैलकुलेशन, चेक योर कैलकुलेशन। अनुष्का आंसर, जील, उत्कर्ष, उत्कर्ष फास्ट बेटा।
सर एक मिनट।
अक्षय, कशिश, क्षमा, आंसर आंसर।
हाँ सर श्योर है, हमेशा डिविजिबल रहेगा।
23 फैक्टोरियल अपॉन 30।
श्योर है
यस सर, आ रहा है डिविजिबल
सर,
हमेशा।
हमेशा डिविजिबल ही आ रहा है सर।
I'll give you I'll give you time to explain your like thought process. No problem. चलो, let's start.
सर
Then
अगर वो 26 होता तो क्वेश्चन इजी
सर
होता।
1 सेकंड।
हाँ, अदर बहुत ही सिंपल हो जाता। शिवांग, विजय, check your answer. A number A is a number like बहुत बड़ा सा आएगा ना बेटा। अनुष्का, ऋषभ, चेक करना पड़ेगा बेटा। चलो डिस्कस करें, राइट। एक अच्छा मौका मिला, राइट। शिवांग, यू वांट टू आस्क एनीथिंग बेटा? यू वांट टू से एनीथिंग? शिवांग? यस, ओके 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 संजना, टेक योर टाइम, 1 minute. Six. You check the calculation.
सर मॉड 13 है।
हाँ,
मॉड 13 है।
क्या निकाला तूने?
सर नहीं पूछ रहा हूँ।
हाँ, obviously
हाँ
you have to divide by mod 13. So Jayesh and Shreyaj, right? So first your turn. You all are giving you the answer key. This is always divisible. So 0, right? Why and how? Yes, fast.
हाँ तो सर हम 23 फैक्टोरियल को उधर ट्रांसपोज करें तो सर 23 फैक्टोरियल प्लस प्लस 23 फैक्टोरियल प्लस 23 फैक्टोरियल बाय 2। फिर सर वैसे करते करते हर एक केस में 13 आ रहा है।
वो केस को एक बार सोचो तो जिसमें 13 होगा, 1/13 होगा, वो वाले केस को।
हाँ सर। ओ
वो केस कुछ गड़बड़ हो रहा है क्या?
ये
And one of the term is there, right? 1/13, कोई ना कोई टर्म तो एक बार होगा ही ना बेटा, right? So 1 by
कंटिन्यूअस समेशन था।
when you are multiplying this, so you are getting 1 into 2 into 3 up to 12, into 14 into 15 into 16 up to 23. Right?
बस सर अगर हम दोनों साइड को 23 फैक्टोरियल से मल्टीप्लाई करें तो
उसको करने के बाद ही जो आया वो लिखना बेटा। उसके अलावा और भी टर्म आएंगे, like in this term, the first term you'll get 23 factorial, second term you'll get 23 factorial, but the number 2 is not there, right? For third one, 23 factorial, but 3 is not there. So each and every term except this one will contain 13. Right? So each and every term will be divisible by 13 except this one, what it is written in this, right?
सर वो डॉट दिखा ही नहीं, मुझे लगा सिर्फ इन तीनों का सम है।
Yes, no comments. Is factorial 12, and this is 1 into 2 into 3 up to 10. This is 10 factorial. So 12 factorial into 10 factorial. That we have to find, right? 12 factorial into 10 factorial. So what is this 12 factorial when divided by 13?
Minus 1.
Very good.
-1.
Formula only, right? -1. And for, I can say 12 into 11 into factorial 10 congruence to -1 mod 30. So this is -1 into -2. This will be 2 into 10 factorial is equal to -1 mod 13. So we have to find inverse of 2. Inverse of 2 is the -7, right? So this will be -7, what we are getting. So this into -7. So I guess 7 you are getting, na?
Yes, sir.
Not divisible, Sanjana. This is not divisible. That's the reason it's coming as the remainder. Okay. Very good. फिर से उत्कर्ष, प्रत्युष and Sivank, Rishabh, very good. At last, you all have the answer, right? So this is very simple theorem, right? Basic theorem. Only you have to concentrate for.
Sir, it should be -1. Remainder -1 होना चाहिए सर, और basically 12.
Which one, beta?
सर यही वाला।
-1 into 7, ना?
सर नहीं सर, क्योंकि अगर हम लोग बाकी सबको काट देंगे तो हम लोग का 1/13 में जो आएगा 12 फैक्टोरियल इंटू 14 इंटू 15 इंटू 16 इंटू जाएगा 23 तक। तो उसमें 14 इंटू 15 इंटू 16 इंटू 17 उसको मैंने 1 इंटू 2 इंटू 3 इंटू 4 इंटू 5 इंटू 6 इंटू -6 इंटू -5 इंटू -4 इंटू -3 इंटू -2 इंटू -1 mod 13 हो जाएगा। तो दैट मीन्स बेसिकली 720 इंटू 720 विच इज 518400 mod 13 विच इज 12 mod 13.
Not at all required for this. See, 14 you can write 1. Remainder is 1 when you are dividing by 13.
सर एग्जैक्टली वही मैंने यूज किया।
So 1 into 2 into 3 up to 10 is factorial 10 only, right? Up to 1.
अच्छा,
So
हाँ
factorial 10 only. On factorial 10 you are just finding from this 12 into 11, right?
तो मैंने एक्स्ट्रा 2 ऐड कर लिया। हाँ -7 सही।
No, but what you are doing for that, so we have developed the formula. Nahin. We have developed the formula for that only, na? You have not to do all these things, right? Now, next is the Fermat theorem, right? Let P be a prime number and P does not divides A. P does not divides A, then A to the power P minus 1 congruence to 1 mod P. This is true for all the cases. A to the power P minus 1 congruence to 1 mod P. This is a simple like basic theorem, and obviously you'll get question on this. बहुत सारे variety के question will get. right? P must be a prime number, right? And A is not A and P are co-prime to each other. Right, then we have to find exactly A to the power P minus 1 congruence to, or A to the power P congruence to A mod P. And this, right, we have already proved this. याद होगा सभी को, right? But there is some restrictions on that. That's the reason Euler given the formula for this, how to find Euler.
सर ये जो a to the power p congruent to a mod p है, इस पर restriction है क्या?
हाँ बेटा, आएंगे, अभी बताता हूँ. हाँ, I'm giving you a question. 1835 to the power 1910 plus 1986 to the power 2061, right? Mod 7 के लिए what is the congruency? Simple question. Only you have to use the formula. Take your time. Write down the answer in chat. And congratulations, everyone. India won the World Cup.
हाँ सर, T20 कल देखा था
हम्म
सर। पहली बार मैं 12:30 बजे तक जगा था।
हम्म. अब चल, आदत बन गया तो इट्स गुड ना. आज से पढ़ने के लिए जग जाना.
हाँ सर।
परफ्यूज ऐसे नहीं हंसते. Very good. Devang, very good. Patyush, very good.
Sir, I got disconnected. Can you repeat the question?
Bas written there, beta. 1835 to the power 1910, 1986 to the power 26.
So you have to find the remainder.
Very simple question, direct question, right? I don't know why.
सर हो गया सर, मैंने आंसर भेज दिया था.
Very good, very good, very good. Anushka, check the calculation, check the calculation. Aryan, guys. Receive, check the calculation. Vijay, check the calculation.
सर मैंने भी भेजा.
Very good, Fred, very good. Tanmay,
Yes, sir.
very good. 1835, when you are dividing by 7, what remainder you are getting?
1.
भेज दिया.
1.
Wow.
So 1 to the power anything will be like 1 only. 1986, 1 divided by
7. सर 5 आएगा रिमेनिंग. -1.
-1 or 5?
-2. -2.
-2.
-2, right?
हाँ.
You're getting -2 to the power 2061. So minus is coming out to this, right? Now we have to write 2061. Right? Can I write this as 2 cube to the power? Something like this. And this is 1 only, right? Congruence to 1 mod 7, right? Okay. Okay, everyone. Right? So this is minus sign 1 and -1, that will be 0. So this is always divisible, right? Seven two five seven eight nine to the power 41. Find last 2 digits of this number. Last 2 digits of this number.
The last कितने digits sir?
2 digits.
Okay sir.
Last 2 digits, not last digit.
So last 2 digits निकालना.
सर भेज दिया.
Very good, Akshay. Receive, very good. Aryan, last 2 digit beta. These are the simple question. Either you have to use the power only, or you can say you have to use the Fermat theorem, right? But these
सर
are
भेज दिया.
very good, very good. Calculation check karo Sahaj. Shivank, very good. Everyone, very good, everyone.
तो फॉर्मेट से थोड़ा टफ होगा ना.
Fermat say you have to go with the Chinese remainder theorem also you have to apply. That's really good. Katani, check your calculation. This is last 2 digit will be decided by 89 only, and that is -11 to the power 40, right? minus 11 to the power 41 is same as minus 11 to the power 40 into minus 1. Is this okay? Right, into minus of 11, right? Mod of 100. 11 square, 11 to the power 4, 11 to the power 6, right? 11 to the power 10. But by binary method, you can find all this, right? Either you can go with a binary method or something, you can find this, right? Or 11 to the power 8, you can find, or 10, and 11 to the power 16. And 11 to the power 32 also. This is called the binary method, right? When you want to find the powers, the greatest power, and you have not to apply the any formula, right? So 11 square is ending with 21, right? 11 to the power 4 similarly will be ending with 41, right? Then 11 to the power 8 directly coming to this, right? What is this 11 to the power 8 will be? 11 to the power 8. Yes, anyone? 41 square. What 41 square you are getting?
81.
81, right? And what is the square of this you are getting?
61.
Right? 61, and this will be?
फिर वापस 21.
Right? So I have to take 11 to the power 32 into 11 to the power 8. This one and this one. Is this okay? So this is coming as 0, 1. All you understand this? This is called the binary method. You have not to find out everything, just you can go with this. So 0, 1 into this is minus 11. So this is minus of 11, and that is same congruence to 89 mod of 100. We can find this by Chinese remainder theorem also, right? Later on, we'll go for that, right? So I hope you everyone is getting this. Very good, Sanjana, very good. Tanmay, Anushka, Devang, very good, right? So when we have to find the last two digits, it's not necessarily always you have to go with the numbers, right? What is given in the forms, right? Like if I'm giving you next question, please. Okay, everyone, right? So this is on Fermat, right? Fermat theorem, and when we have to find the powers, right? When divided by some numbers or something, right? Just a minute. Right. So in these type of question or the Fermat theorem, right? Directly we have to apply the basic fundamental of the numbers, and I hope you all are getting this thing right. But the best part of this is when we have to apply Euler quotient function. What is this Euler quotient function? And as we have seen, a to the power p minus n congruence to right 1 mod of p. Euler ने एक नए terminology को like he has given. Just see everyone careful now the process is coming into you, right? So please careful, right? यहाँ के this is the theorem that you have to use for the numbers, right? And now we have to use the complete number theory or number system, what we have done, right? So careful, right? What is this? So he has given the complete theorem, like, because this Fermat theorem was applicable in few cases, was not applicable in few cases, so it was not very much prominent, right? So what Euler said, okay, no, change the right basic of this complete theorem. He said, first define a phi of n. What is this phi of n? Phi of n is the number of positive integers less than or equal to n that are relatively prime to n, right? Phi of phi. This is the prime number, right? Relatively prime to n. What is the meaning of this? The phi of phi. So number 5, if you'll see that the number 1, 2, 3, 4, and 5. Right? These numbers are there 1, 2, 3, 4, and 5, right? So this is saying that it's not divisible by which of the number. So like 1, 2, 3, 4. It is divisible by 5, right? Including 1. Right? And for any prime number, you can write this is 5 minus 1. That's number will be 4. Right? If phi 12, you have to find the number 12. What is phi 12? The number 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. What are the number? This is not divisible. Or divisible, you can count. What is the value of P of 12?
Sir, 1 second, आप ऊपर ले सकते हैं.
Write down the definition. Write down the definition.
Yes, sir. Thank you, sir.
और सर इसमें 1 को इंक्लूड करना है ना.
What phi of 12 is coming? What of phi of 12? Write down in chat, please. Write down in chat. Not divisible by Katani. It's not divisible by, right? दोनों प्राइम्स जो होने चाहिए डिविजिबल भी है, साथ ही साथ मेरे पास ये भी है कि दोनों में कोई कॉमन फैक्टर्स आर नॉट देयर, राइट? द कॉमन फैक्टर्स आर नॉट देयर, राइट? इंक्लूडिंग 1. So numbers are 1, right? 5, 7, and 11. Only 4 numbers are there.
Sir, will it not be 8, 9, 10?
So the factor 8 is common to this, right? One of the common factor is coming into this. 4 is a factor. 9, one of the common factor is coming to this. 10 is not co-prime to each other. 12 is also not co-prime to this other. And 2 and 3, 4 are not co-prime to each other, right? Okay. What is phi of 20? $20, right? So you can see 1, 3, 7, 11,
और
13,
9 भी आ सकता है.
15, yes, 9, 17, and 19. So the numbers are coming as it, but it's very true. This will be very difficult when we have to find by counting, right? So the formula for this is, what are the factors, right? 20 the number 20, we can write this as 2 square into 5, right? So what you have to write 1 minus 1 by 2 into 1 minus 1 by 5 into 20. These many factors you'll get that. So you are getting 20 into 1 by 2 into 4 by 5. The number is 8. But if the number is prime, right, I'm saying 17. So obviously we know that 16 factors are there. Because except 17, all the numbers are relatively prime to 17. Is this okay, everyone? Or we can say if n is denoted as, right, p1 to the power n1, p2 to the power n2, up to pk to the power nk, right? So the phi of n is nothing but 1 minus 1 by p1, 1 minus 1 by p2, all the prime factors you have to take in that way. Okay. And few of the formulas given by, so you all understand exactly how to find the numbers on that. Okay, so he has given few theorems on that. First is, if you have to find phi of 25. 25 is 5 square, right? The prime is 25 of 5 square. So Euler given the formula for this, or if you will count this, right, 5 to the power k, or any prime to the power k, right? Especially you can say any prime to the power k, the numbers will be p to the power k minus p to the power k minus 1. Means number will be p to the power k, means 5 to the power k, 5 to the power k minus 1. Means the number will be 5 square minus 5. Right? So this will be 25 minus 5 will be 20. Right? This is the one of the, like, if primes are given, so you have to apply this for how to find this. Second formula he has given ki if this is phi of mn, you can write m into n if m and r co-prime to each other. M and n are co-prime to each other. Directly you can write phi of mn is equal to phi m into phi n. Okay. So now you have to find phi of 360. Write down in chat. But fast. This is one of the best formula when we have to use for, like, we have to find last 2 digit, last 3 digit, last 4 digit, or so on. Just you have to go through this. Not many formulas you can use. 360 is
15 into 24.
अगर प्राइम फैक्टराइज करे तो ज्यादा आसान लगेगा
9 into 4, 9 into 8 ना,
हाँ सर 8
into 5, right? So you can write this as 360. The best formula for this is
5
1 minus 1 by 9, 1 minus 1 by 2, sorry, 3, and 1 minus 1 by 5. The 3 numbers. This because this is 3 square into 2 cube into 5 to the power 1. So this is 360 into 2 by 3 into 1 by 2 into 4 by 5. Right? $96. Or you can apply the formula. The different formulas are there, but you can write directly in this form also. Okay. Right? Okay, everyone. So what just I'm showing you. Write it down, write it down. Just take your time. Now the main question will come on this, right? After forma, right? And Wilson, then
Yes, sir.
okay. So you all know now how to find this, right? अगर मेरे को find करना है तो you know there is a formula, right? Directly you have to use the formula, and obviously with the formula, right? P1, 2, 3, 4, or any prime numbers we have to take, right? Then we have to apply the formula for that, right? P of any number and the properties for like different number, right? So what Euler said in no. Don't use a to the power p minus 1 congruence to 1 mod p. He said, instead of, we can apply the formula, as a formula, we can apply a to the power p n congruence to 1 mod n. Right? A to the power p n congruence to 1 mod n. Right? So that will give you the, like for any number you can say that will give you the answer for the formation of the number, right? And obviously GCD of a and n is equal to 1, right? In this case we are not saying ki n is in prime number or something, right? The restrictions was ki n is prime or something is not given there, right?
तो अब n कोई भी इंटीजर हो सकता है.
हाँ, जितने प्राइम फैक्टर्स एंड ऑल है ना, उसके लिए भी वी कैन अप्लाई दैट, राइट? एंड पावर बहुत ही सिंपलेस्ट फॉर्म में यू कैन रिड्यूस द पावर इनटू द सिंपलेस्ट फॉर्म. ओके.
Yes, sir.
So if I'm giving you 3 to the power 345 mod 100, can you find this? Directly coming to the question. Right? Fine. Fine. Done, everyone? Fast, 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 fast.
सर भेज दिया.
Very good, very good. Means you are saying 03. Where? Means you are saying 03 is the number.
Yes, sir.
Okay. Okay, bachos. Okay. Bachos, bachos. 21. Now you have to find 3 to the power 21, na? Just you have to see for 21 what number you are getting for last two digit.
Sir, is in the answer in the chat.
Very good, Sanjana. Very good, everyone. Let's see. So, what is phi of 100?
40.
40.
Means 3 to the power 40 congruent to 1 mod 100. Right? Three to the power, and then we can say 3 to the power 40 8 congruent to 1 to the power 8 mod 100. What is this number is coming? 320. 3 to the power 320 means we have to find only 3 to the power 21. 3 to the power 21, right? Again, if you want, you can apply the binary process. Binary process means 3 square is 9, right? 3 to the power 4 is 81, right? 3 to the power 8 is what we are getting?
Sir, 61.
Right? We have already found that, right? And last is 3 to the power 16. What is it?
21.
Right? Now, again, I have to go for these two components, right? So this I can write 3 to the power 16 into 3 to the power 4 into 3 to the power 1, right? This giving me 21, this one giving me 81, and this one giving me 3. So what is the product of this two?
3.
Mod 100. Is this okay? These questions are very simple, right? And when you have to find just like this, you have to remember if you have to find, this is a way, like you are going with the binary, right? 2, 4, 8. So easily we know we can reach there. So 100% we can write each and every number with the binary, right? We have already studied that, right? Problem to any, we can write the numbers, right? But what is the use of this? Now, these are the simple concepts directly question is giving this, right? But obviously, you know, like all the examination are process of rejection examination, so you will not get the question directly or something like when we have to. One question I'm framing, right? This is 2017 to the power 2018 plus 2018 to the power 2019 plus 2019 to the power 2020. Right. Last two digits of this number. Take your time.
Last two digits.
Yes. But this is not the question, just from a warm up I am giving you, right? The original question will be different.
तो सर ऐसे हार्ड होगा कि इजी?
अच्छी बात है, इससे तो इजी ही होगा ना बेटा। Okay, do it fast.
Sir, we have to find this mod what?
100. Last two digit. Fast this time, everyone.
सर भेज दिया।
Very good. Aryan, very good. बहुत फास्ट किया आप लोगों ने, वेरी गुड, वेरी फास्ट कैलकुलेशन। शिवांग, द कैलकुलेशन। Katani,
Yes, sir.
do it, Shama, do it, Kasis, Akshar.
Yes, sir.
Curse, do it fast, do it fast. Very good, Katani, very good. Rishabh, check your calculation again. Anushka. Shivang, calculation check again.
सर मेरा सही है क्या?
सही लग रहा है बेटा, देखता हूँ। लेट्स स्टार्ट करें क्या? संजना, डन। Done, everyone? तन्मय,
हाँ सर आ गया बस 2 मिनट।
the first number is nothing but 17 to the power 2018. Second number is 18 to the power 2019. And this is 19 to the power 2020. Right? Yes. Please tell me what you are doing, how you are getting the numbers. Yes. Shreyansh, explain beta.
यस सर। सर हम लोग को तीनों का मॉड 100 कैलकुलेट करना है। तो सर हम लोग 40 में उसको 17 मॉड 2018 है।
Yes.
हाँ, तो सर हम बाइनरी से उसको कर सकते हैं। तो हम 17 के पावर्स निकालेंगे, लास्ट 2 डिजिट्स। सर मैंने तीनों को वैसे तीनों का लास्ट मॉड 100 निकाला और लास्ट में मेरे को 9 + 32 + 1 आया, क्योंकि 2009 to 2020 1 मॉड 100 आ रहा है। और फिर उसके पीछे वाला 32 मॉड 100 और 20।
वर्केबल नहीं लग रहा बेटा।
सर तीनों का मॉड 100 निकाल के कर सकते हैं ना?
कैलकुलेशन बेटा, मॉड निकालना इतना आसान नहीं रहेगा। 17 to the power 2018 इफ यू वांट टू गो ना वो विद द बाइनरी, राइट, विद द बाइनरी, तो ये बहुत बड़ा मेरे कैलकुलेशन चला जाएगा। दैट्स नॉट
सर मैं बताऊं सर 18 तो 2019 को 17 + 1 तो 2019 लिखेंगे और 19 को 17 + 2 तो 2020।
उससे बेटर तो यू कैन गो विथ 20 - 3, 20 - 2 एंड 20 - 1।
हाँ
हाँ,
सर अगर हम 500 को 40 यूज करें तो अगर हम 2019 टू द पावर 2020 मॉड 100 के लिए इलियस थ्योरम यूज करें तो 2020 मॉड 40 = 20 आ जाएगा। तो सर हम फिर स्क्वायर करते जाएंगे तो सर लास्ट में आ जाएगा कि 1 मॉड 100 आ रहा है लास्ट में।
दिखाता हूँ। First thing is a Euler-Toty functions, right? So obviously we have to find for mod 100, right? For mod 100, we know that the phi of 100 is what? What is phi of 100?
40.
40, right? Means 17 to the power 40, right? Congruence to 1 mod 100. Is this okay? इतना प्यारा सा बात उन्होंने बोल के रख दिया, देख रहे हो? Always you are getting the number, right? Means 17 to the power 40 congruence to 1 mod 100. Right. Now this is 40, so we are giving the power 500. So only you are getting 17 to the power 18. And for the second one, you are getting, right, 18 to the power 19, or for third one, 19 to the power. Right. Now you can apply something like it's as we were saying, 20 - 1 to the power 18 plus 20, or you can go with the binary one, is 17, right, or 19 square. This is 20 - 1 to the power 20. So always you will get 1 from this, right? 0, 1 from this. What you are getting from this, these two, this is -2 to the power 19, but one more term is coming in this, na? -19 and -3 to the power 80. But again, one more term will come into this. You have to take care of that also. Right? Or we can go with the binary of this, like how to go for the number on this.
ये से मैंने बाइनरी यूज किया वहां से.
So 17 square is what?
289.
89. 17 to the power 4 is 89 square is
21.
what you are getting?
21 आएगा.
Square is 21, right? 17 to the power 8 is
41.
17 to the power 16,
81.
81, right? What we required 16 plus 2, right? So minus 11 into minus 19, right? 89 I'm writing minus 11, or 81 I'm writing minus this. So this will be a very simple, right? 09 I'm getting from this. Is this okay? यही आया था? Right, for 18,
yes sir.
18 to the power 19, right? 18 square. What you are getting as 18 square?
24.
24.
24. 18 to the power 4.
76.
76.
और फिर से 76 चलता जाएगा.
हाँ?
हाँ, फिर 76.
6 is
और फिर अगर
same as now minus 24.
अब सर 76 ऑन लूप चलता जाएगा.
Right? So 16 will be 76 only. So for this you are getting 76 into 24 into 24. Something like this now. What we required? 19. So 16 power of this, 2 power of this, and 1 power of 24. What number you are getting from this? 76 into 24, 24. 76 square. Again, 76, I guess, na?
Yes sir.
Right? Something like this you are getting. Is this okay? This 20 minus 1, इसमें binomial सोच रहा था मैं. 20 minus 1 to the power 20 ना, तो last term will be plus 1, and before that term is minus 20 into 20, right? That will be minus 400. So all 2 zeros are coming from this, and before that the number is 3 zeros are coming into this. So that number could be going in that way, right? Right. So good one. But what I want, right? मुझे ये नहीं चाहिए थी. मैंने तो just एक question देने के लिए just I have given you the question. Actually, what I want from this question is 2017 to the power 2018 to the power 2019. Find last 2 digit of this number. Is this okay? Or power to the power to the power, right? 2017 to the power 2018 to the power 2019. 3 powers are given. Or if you need, I can say like 5 to the power 231 to the power 72. Something like that. Anything I can write, and then we have to find the numbers.
Sir.
Right? Yes.
सर इसमें पहले दो का mod 100 करने के बाद थर्ड वाले को करना है कि तीनों को एक साथ करना है?
बेटा ये पूरा जो नंबर लिखा हुआ है ना, इसका लास्ट 2 डिजिट निकालना है.
तो सर इसमें ऐसा कर सकते कि पहले दो को साथ में लेके उसके बाद थर्ड को लेके?
व्हाट इज पहले दो का मतलब?
2017 टू 2018 मॉड्यूलो 100 करके
a to the power b to the power c होता है ना, इसका मतलब होता है a to the power b to the power c.
अच्छा ओ ओके
First you have to tackle down this b to the power c, then it will be applied into a,
हाँ ओके सर
right? This is the application of Euler-Totian function. So should I start this? या मैं कुछ
सर
hint?
2 मिनट।
Okay, take your time. This is the best example of Euler-Totian function. So please careful, right? This is a simple question. 100% you'll get that.
So last two digits.
Last digit. Very good, Anushka. Very good. Very good.
सर मैंने ही भेजा
Very good, Saj. Very good. Very good. Should I start?
यस
Utkarsh, done, beta? Actually, Anushka, what you have done, beta? Explain.
सर पहले मैंने 2018 रेज टू 2019 को mod 100 किया, फिर जो मुझे वैल्यू आया फिर मैंने उसको 2017 में पुट करके अगेन mod 100 किया तो फिर 21 आया।
2019 का mod 100 क्यों किया?
सर बिकॉज उनका मुझे फिर लास्ट टू डिजिट्स अगर पता चल जाएगा तो 2017 के ऊपर अगर मैं वो लास्ट टू डिजिट्स लगाऊंगी तो बस होपिंग कि मिलेगा।
थोड़ा सा और सोचो इस बात को। वेरी गुड ना, थोड़ा सा और सोचो इस बात को। यस यस रेज।
और सर मैंने भी वही किया क्योंकि सर लास्ट टू डिजिट पहले ऊपर का निकालना पड़ेगा क्योंकि ए रेस टू बी रेस टू सी में बी रेस टू सी पहले सॉल्व करना है तो वो सर 2082 2019 32 और लास्ट डिजिट तो फिर डायरेक्टली कैलकुलेट कर दिया।
तब वो क्यों निकाल रहे हो आप? इसका mod 100 क्यों निकाल रहे हो? इसका
क्योंकि सर आपने ही बोला कि हमें पहले बी रेस टू सी सॉल्व करना है उसके बाद ए से डील करना है उसके आंसर के साथ।
सी में why you are going for mod 100? आई एम आस्किंग।
क्योंकि सर लास्ट टू डिजिट्स निकालना है ना।
लास्ट टू डिजिट तो ए का निकालना है, बी इज टू सी का थोड़ी निकालना है।
सर पर लास्ट टू डिजिट्स पावर के भी लास्ट टू डिजिट पे डिपेंड करता है तो सर अगर हम बी रेस
ये इस थ्योरी को थोड़ा चेक करो, क्या ये जो आप बोल रहे हो कि लास्ट टू डिजिट पर डिपेंड करता है पावर्स के कारण, उसको थोड़ा सा चेक करो आप। कसिस प्लीज जो आपने लिखा, प्लीज एक्सप्लेन योर पॉइंट. Process. Are you there? आवाज नहीं आ रही बेटा आपकी. See everyone, see, ध्यान से. We have to find 2017 to the power anything n mod of 100, right? So first I have to find what is mod 100, p of mod 100. Now p of 100 is what? 40.
40.
Means I have to write down this 2017 to the power 40 congruent to 1 mod 100. Is this okay, everyone? Is this okay, everyone? 2017 to the power 40 is congruent to 1 mod 100. Is this okay, everyone? क्या ये सही है? Now, if you'll see this, now this n I have to write is in the form of 40 lambda plus remainder form. Then only I can say if this n I'm able to write it down in the form of 40 lambda plus r form. So I'm able to write down 1730 to the power 40 lambda into 7 r form. Is this okay? And this value will always give you 1. So only we have to find this one, right? Means what I have to do with the powers? Power must be in the form of 40 lambda plus r form. Means 2018 and 2019 to the power 2019, right? Giving some number mod of, right, phi 40. Can I say this? Can I say this? क्या मैं ये बोल सकता हूं कि अगर मेरे को ये मिल जाए कि phi of 40, right, phi of 40 से when I'm dividing this, so this, what is the meaning of this? Means we are getting, sorry, phi of 100, right? Phi of 100 means this I have to write down mod of 40, right? So this number r will give you what remainder you are getting when you are dividing this to the power 2019. And if 40 mod means 20 or 20 to the power 2019 r mod 40. Is this okay? Can you find this? Can you find this mod 40? Right? But both having the same factors, right? See, this is divisible by 2. This is also divisible by 2. So I'm not able to find it directly, right? So for that, we have to use CRT. What is this CRT? Chinese remainder theorem, right? This is always divisible by 40. Can I say this? Right? This is always divisible by 40 when this will be having multiple of 5, but this not having multiple of 5. So this is always divisible by 4, but not by 5. Right? Or this is divisible by 8, but not by 5. So I have to see like what I'm getting with mod 5 and what I'm getting with mod 8. Right? This two prime factors are. So when you are dividing this by 8, right, what number you are getting? When I'm dividing this by 8, I'm getting this number. When I'm dividing this by 5, I'm getting 3 to the power 2019. And what this 3029 when you are dividing by 5? So 3 into 3 to the power.
Sir, 2 mod 5.
2 mod of 5, right? 2 mod 5 means all the number is in the form of what? 5 lambda plus 2, right? क्या क्या numbers आ सकते हैं मेरे पास? 5 lambda plus 2. So this number could be 7, 2, 7, right? 12, then 17. All the odd numbers are not possible, right? Because it has to be divisible by 8, right? So what number you will get when this will be divisible by 8?
32.
Right? So number is 32. Is this okay, everyone? So when you are dividing this by, so this is coming in the form of 40 lambda plus 32. That you have to do, right? Right? So I can write this as 2017 to the power 40 lambda, 2017 to the power 32. Are you getting this? Are you getting this? Right? Right. Next lecture में we have to go with this. तो दो चीजें हैं जो हमारे बचे हुए हैं. This week only I have to complete both this. The first is Euler-Totian function जो हम लोग यहाँ पर कर रहे हैं उसके अभी 3-4 और uses हैं that we have to do and quadratic residue, right? ये दो चीजें हम लोग को करनी है जो यहाँ पर हमारे को आगे यूज होंगे, right? And हाँ, third is the digit of the functions, right? How many digits are there, possible number of digits, and जो पावर में मैंने यहाँ पर 2 और 3 पावर के दिखाए, like you can see the power of 2 and power 3 powers are there. We have to go with the 10 or the like more than 10 powers, right? How to deal with those questions, right? So that will be like in 1 hour or 2 hour span we can do that, right? So next lecture I'll start with that. Okay, everyone. Okay.
Yes, sir.
Right. So please, and my next lecture will start in 5 minutes.